Hello everyone, this is Adnan and welcome to Chemistry with Adnan. On this YouTube channel, I'm covering the entire syllabus of IGCSE Cambridge Chemistry. The course code is 0620. And for free lessons, like live lessons, you can join my community on school.com with the name of High School Chemistry. And the link is given in the subscription in the description below. Okay, so in this lesson, we will be covering this is a start. This is a new chapter, chapter 8, the periodic table. In our previous lecture, we completed acids, bases, and salts, chapter 7. So the first topic of this chapter is 8.1, arrangement of elements. And the first subtopic is describe the periodic table as an arrangement of elements in periods and groups and in order of increasing proton number or like atomic number, right? So basically, periodic table is an arrangement of elements. In a periodic table, elements are arranged on the basis of their increasing atomic number, and they are arranged so that we can study them effectively because all the elements with the same properties, they are in the same group, right? So we have 8 groups in the periodic table. The vertical columns from left to right, they are called groups, and we have 8 groups in the periodic table. As you can see, this is group 1. Remember that hydrogen is not a part of group 1. It starts with lithium, sodium, potassium, rubidium, cesium, and francium. This is group 1. And then group 2 is beryllium, magnesium, calcium, strontium, barium, and radium. And then we have group 3, group 4. These are non-metals after group 3. So from group 4 to group 8, these are non-metals. So group 1, it is called the alkali metals. Group 2, alkaline earth metals. That's the boron family. Then that's the carbon family, nitrogen family, oxygen family. Group 7, they are called halogens. And group 8, they are called the noble gases, right? So the periodic table begins from hydrogen. It has the atomic number of 1 with the number of protons. And then we move on in each, okay, these are periods. So horizontal rows from left to right, these are periods. And we have 7 periods in the periodic table. So 1, 2, 3, 4, 5, 6, and 7. So these, these are basically written, just to, compress the periodic table. So this is basically an extension of period 6, and this row, that is the extension of period 7, right? So I hope this is clear. Now describe the periodic table as an arrangement of elements in periods and groups and in order of increasing proton number. Yeah, so proton number is the same thing as the atomic number. So helium has 2 protons. So then you come back here. So lithium, then beryllium 4. Boron has 5 protons, or the atomic number is 5. Carbon is 6, 7. Oxygen is 8. Fluorine is 9, and neon is 10. So this is how, and this element, organeson, this has the atomic number of 118. Right? So I hope this is clear. So this is the last or the most recently discovered this is an artificial element which we created in the lab. So yeah, so this is the periodic table, right? So now groups, how many groups are there? We have 8 groups. They are numbered in like Roman numbers, and these are called transition metals. We skip these for now, and we will talk about this in more detail in our upcoming topics, right? So that's transition metals. Okay, so now we move on to the next topic. It says describe the change from metallic to non-metallic character across a period, right? So you can see here that as we move from left-hand side to the right-hand side, so the metals, they eventually change into non-metals, right? So let's take a look at the example of period 2. So this one, so lithium, beryllium, and boron, these are 3 are metals, and then carbon all the way from carbon to neon, these are non-metals, right? So describe the change from metallic to non-metallic character across a period. So as we move from left to right in the periodic table, across a period, metallic character, it says describe the change from metallic to non-metallic. Yeah, so the metallic character, as we move across the period, metallic character decreases and non-metallic character increases, right? So I have included a question here which says that period 3 of the periodic table is shown, which increases from sodium to argon across period 3. Density, no, density is decreasing as they are changing from solids to gases. So this cannot be the answer. Melting points, no, they increase first, but then they suddenly decrease as we enter the territory of non-metals. So we have gases on the right side, so their melting points cannot be higher than sodium or magnesium or aluminum. So then a non-metallic character, yes. So you can see that on the left hand side, the first three, 1, 2, 3, and 4, silicon is basically a metalloid, but yeah, so these are metals, sodium, magnesium, and aluminum. And then phosphorus, sulfur, chlorine, and argon, they are pure non-metals, right? I hope this is clear. So non-metallic character is the answer. It is increasing from left to right. So you see, non-metallic character, it increases. The number of electron shells, no, they remain the same because we are in the same period. Remember that while moving across the period, so the number of shells, they remain the same, right? So now let me explain something here to so that you can understand it better. What is meant by a metallic character, right? The ability to lose electrons. So what is a metallic character? So the ability to lose electrons. And non-metallic character is the ability to gain electrons. Remember that. So as we move down the group, right? So the metallic character increases because electrons can be lost more easily because of the shielding effect, and since the outer electron is further away from the nucleus, right? So let me give you an example. Lithium, for example, it is in period 2, so it will have two shells. That's the nucleus, so 1 and 2, right? And we have 3 protons in the nucleus. So the outermost electron, which is very close to the nucleus, it is held strongly by the nucleus. But if you compare francium with lithium, right? So now in francium is in period 7. So we will have 7 protons and 7 shells. 1, 2, 3, 4, 5, 6, 7. Sorry, we don't have 7 protons. We have lots of protons. Let me check the uh, atomic number. It's 87. Yeah, so we have 87 protons, but since we have so many electron shells, and they block the pulling power of the nucleus, right? So, and since the outer electron is far away from the nucleus, so these protons, they are unable to hold tightly onto this outermost electron, right? So it will be lost more easily. So what is metallic character? Metallic character means that the ability to lose electrons, right? So francium will have a greater, higher metallic character because it can lose electron more easily as compared to the like lithium, which is at the top of the group, right? So similarly, if you look at fluorine, so fluorine is a non-metal, and now they gain electrons. So the there the non-metallic character, it decreases down the group, right? And because let me explain comparatively. So fluorine, for example, it has 9 protons in the nucleus and only 2 shells. So the electron that is in the outer shell, it will be held tightly by the nucleus, and at the same time, any electron that comes closer to fluorine, it will be captured by fluorine so that it can have a complete outer shell, right? So now let's compare fluorine with iodine. So iodine will have a certain number of protons, but it will have one, two, three, four, one, two, three, four shells. So similarly, like just like francium, so it will have, you know, the shielding effect, and yeah, so now it cannot gain an electron because the nucleus, the pulling power of the nucleus is being blocked by, the core, shells, inner shells, right? So that is why it has a less non-metallic character, because of the shielding effect and because of the distance, the radius of this atom, it is unable to efficiently gain electrons, right? So I hope this is clear. Now we move on to the next part. Now, subtopic 3, describe the relationship between group number and the charge of the ions formed from elements in that group. I have explained this topic before in the first 2 or 3 chapters, where I've explained how to write the formulas for ionic compounds, and there I've explained it, but I'll explain it again here. So you see the describe the relationship between the group number and the charge on the ion. Yeah, so these are metals, right? So group 1, group 2, and group 3, right? So they lose electrons so that they can have a complete outer shell. So in group 1 we have only one electron, and when they lose that electron, they will have a complete outer shell. Lithium, for example, it has 2 electrons in the first shell, and it has 1 electron in the second. So when it loses this outermost electron, so it will have the electronic configuration of helium. Lithium plus will have the electron configuration of a helium, right? 2. So before it was lithium has the electron configuration of 2, 1, but for lithium plus the electron configuration is 2. So that is the electron configuration of a noble gas, and now it is stable. So it will lose 1 electron, and they will group 1 metals, they will make ions with a +1 charge. Similarly, group 2 metals, they lose 2 electrons, and they will have a 2 + 2 charge. And group 3 metals, they lose 3 electrons, and they will have a +3 charge, right? So now carbon group +4. Now the non-metals, like nitrogen, for example, it has 5 electrons in its outer shell. 2, 5. That is the electron configuration of nitrogen. So 2 electrons in the first shell, and 5 in the second, right? 1, 2, 3, 4, and 5, right? It needs 3 more to make it 8, so it will gain 3 electrons. So group this is group 4. The group 5 elements, they will make ions with -3 charge, because they will gain 3 electrons. Group 6, they will gain 2 electrons, because oxygen, the electronic configuration is 2, 6. So it needs only 2 electrons to make it 8 to have a complete outer shell and gain stability. So group 8 ions, elements, metals, they will have a -2 charge. And the halogens, group 7, they will gain 1 electron. Fluorine, the electronic configuration is 2, 7, so it needs only 1 to make it 8 and gain stability and achieve the electron configuration of neon, a noble gas. So and they will have a charge of -1, right? So you have to remember this, the relationship of group number with the charge of the ion that the metal or non-metal will form, right? So I hope this is clear. Now we move on to the next subtopic, which is explain similarities in chemical properties of elements in the same group of the periodic table in terms of their electronic configuration. Yeah, so this is important to understand. I'll use the diagram of the periodic table above. So group 1, remember group number, a number of valence electrons, right? Yeah. So if the number of electrons in the outer shell, they are the same, so they will have the same chemical properties, right? It categorically says that chemical properties. Okay, so group 1, they will have 1 electron in the outer shell. Group 2, they will have 2 electrons. Group 3, they will have 3 electrons in the outer shell. Group 4 will have 4, 5, 6, 7, and group 8 will have 8 electrons in the outer shell, and their outer shell is complete. That is why they don't react. They are called noble gases. They are very stable, the most stable elements in the periodic table. So I hope this is clear. So explain similarities in the chemical properties of elements in the same group of the periodic table in terms of their electronic configuration. Yes. So if the outer shell electrons are the same, so they will have the same chemical properties. So lithium, for example, its electron configuration is 2, 1. So in the outer shell, you see there's 1 electron. Now in sodium, for example, so we have 2, 8, 1. So again, we have only 1 electron in the outer shell. So lithium and sodium, they will have the same chemical properties. Potassium, again, so the electronic configuration is 2, 8, 8, 1. 2 electrons in the first shell, 8 electrons in the second, 8 electrons in the third, and there's 1 electron in the fourth shell, right? So you can see that the elements in the same group, they have the same number of outer shell electrons. Remember that, right? Yeah. So yeah, 2, 7. So fluorine has like 7 electrons in the outer shell. Now chlorine will have 2, 8, 7, and iodine will have 2, 8, and 8, and then 7, right? So in the outer shell, they have all 7 electrons. So these elements, they will also have almost the same chemical properties. So that is the relationship between the electron configuration and the chemical properties of the elements, right? So now we move on to the next one. Explain how the position of an element in the periodic table can be used to predict its properties, right? So yeah, so you just need to know that in group 1, 2, and 3, these are metals, right? And they will have like all the properties of metals. When they will react, they will lose electrons. They are conductors of heat and electricity, right? And they have high melting and boiling points. So, and if you know the group of the element, and let's say if it is in a non-metals, like group 4, 5, 6, 7, so they will gain electrons mostly when they will react, and without a few exceptions, they will be non-conductors, right? So you just need to divide, you just need to figure out whether the element is a metal or a non-metal by identifying its group number. So these are non-metals. Yeah, and they will be non-conductor. Yeah, they will have low melting and boiling points, right? Melting points and boiling points, and yeah, they will have low density. So these are all the properties. Okay, so now we move on to the final, the last topic of subtopic of this topic, 8.1. So arrangement of elements. So, and this is for the supplement or extended version of the paper. Core students will not be assessed on these topics, these concepts. So subtopic 6, it says that 8.1.6, identify trends in groups given information about the elements. So the melting points. So you need to remember that melting points. So uh, okay, so yeah, so you need to discuss, basically you need to know the three types of properties, right? The melting points, and the like density, and reactivity, right? These are the properties that we should know, right? So The first one is melting points. Yeah. So melting points, remember that they decrease down the group, right? So decrease uh, down the group. So lithium, like for example, lithium will have a higher melting point as compared to francium, right? So that will have a higher, lithium will have a higher melting point and francium will have a lower melting point. So density, it also, it increases down the group. It increases down the group, and reactivity, the reactivity for metals. Remember that for metals, reactivity uh, increases down the group because they can lose electrons more easily, and metals, they react by losing electrons. For metals, reactivity increases, and for the non-metals, reactivity decreases, right? Reactivity decreases. So if you remember this and if you keep this in mind, you will be able to answer questions. So I've included a sample question here, which says that which statements about the trends uh, of the which statements about the trends across the period of the periodic table are correct. Number one, aluminum is more metallic than sodium. Two, beryllium is more metallic than carbon. Three, boron is more metallic than lithium. And four, magnesium is more metallic than silicon, right? So the answer is C. Boron is more metallic than lithium because we studied that, metallic character, it, you know, uh, boron is more metallic than carbon. Okay, we have to choose, yeah, two and four, yeah. So beryllium. So I've added a question here which says that question number 6, like which statements about the trends across a period of the periodic table are correct? Number one, aluminum is more react and more metallic than sodium. Two, beryllium is more metallic than carbon. Three, boron is more metallic than lithium. Number four, magnesium is more metallic than silicon. So we learned that the metallic character across the period, it decreases from left to right or across the period, right? So the answer is C, 2 and 4. So beryllium is more metallic than carbon because beryllium is on the left side, and carbon is on the right side. So carbon will be more non-metallic or less metallic than lithium, right? Or beryllium. Yeah, so beryllium is more metallic than the carbon. And the point number 4, magnesium is more metallic than silicon. So magnesium is also on the left side of silicon. So silicon will be less metallic or more non-metallic, and magnesium will be more metallic or less non-metallic. So this is how you have, so statement number 2 and 4, they are correct. And statement number 1 and 3, they are incorrect, right? So now this is a question for extended students, I believe. So some information about elements in group 2 of the periodic table is shown. So which row shows correct trends in reactivity, density, and melting points? You see, these are the three parameters that we studied: metallic melting points, density, and reactivity. And you will be assessed on these three. So, you can take a screenshot, or you can, if you're taking notes, so you can write this down. This is very important. Now, on the basis of this information, you will have to answer these questions, right? So, okay. So reactivity, it increases yeah, since group 2 they are metals, right? So remember that the reactivity, it increases down the group. This is correct, right? So A decreases down the group, incorrect. It decreases down the group, incorrect. So this one is also correct. Now density increases down the group. Yes. Melting point, like density, what did we learn here? That density, it increases down the group, right? Yeah, so this is correct. But since this is not correct, so this cannot be the answer. This one is also correct. Melting points, they also, um, you know, uh, they decrease down the group, right? Now, density, there is no clear trend. And melting, yeah, you can see here that in density, this is the data that they have given. So you can see that there is no clear trend, right? So it is not decreasing down the group. So this cannot be the answer. No clear trend. So yeah, no clear trend. But since the first one is wrong, so this cannot be the answer. This is correct. No clear trend. This is correct. Melting points, they are decreasing. So, this cannot be the answer. And increases down the group, no clear trend, no clear trend. D is the answer. So I hope this is clear. And you need to understand, you need to analyze the data based on reactivity, density and melting points, right? So you can see that the reactivity is increasing. So it is taking less and less time to react, right? So the more time or the more seconds taken, and the substance will be less reactive, and the less time taken, the substance will be more reactive. So this was our lesson for today. And if you need free one-on-one live lessons with me, you can join my community on school.com with the name of High School Chemistry, and the link is given in the description. So I hope to see you in the next one soon. Take care. Goodbye.